Welcome back, guys. Today we'll be doing CAPE Unit 2, 2008, Question 6. It's a complex number question. Let's get started. This question is asking to express the complex number 2 minus 3i over 5 minus I in the form lambda open bracket 1 minus I. Now, what we're going to do is find the conjugate of the denominator, then multiply the numerator and denominator by this conjugate. Now, the conjugate for 5 minus I is 5 plus I. So I'll multiply both numerator and denominator by 5 plus I. So let me go ahead and put these in brackets so that you can see that we have to expand. So expanding, multiplying 2 times 5, that will give me 10. So I go ahead and write my 10. Then multiplying 2 times I, that will give me positive 2i. So I rewrite this as plus 2i. Then minus 3i will be multiplied by the bracket 5 plus I. So minus 3i times 5, that is minus 15i. Then we have the minus 3i times I, and that will give us minus 3i squared. So let me go ahead and write my minus 3i squared. Now I'm going to multiply in the denominator. If you realize this, the signs are different. So we're going to have cancellation of the I. So 5 times 5, that's 25. And then 5 times positive I, that gives me positive 5i. So I'm going to write plus 5i. Then I'm going to multiply the minus I times 5. That gives me minus 5i. So always when you multiply a bracket by its conjugate, the center will cancel, eliminating the i's. Now multiplying minus I times positive I, that will give me negative I squared. Now I square, remember, let's recall, I square is negative 1. So don't forget that I square is negative 1. So we can replace this I square here with minus 1. And that means negative times negative, that will give me positive. So what I'll have here is plus 3. Same in the denominator, I square is negative 1. So that means this minus sign will change to a positive. So this will become plus 1. Also in the center, the 5i minus 5i, that cancel. So what do I have? So in my numerator, add the real, so the 10 plus the 3, that's 13. Then we have 2i minus 15i, that's minus 13i. In the denominator, we have 25 plus 1, so that gives me 26. Now, I'm going to put a bracket in the numerator, and if you realize 13 is common, so I can factor out 13 in the numerator. So factoring out 13 inside my bracket, I will be left with 1 minus I all over 26. Now 13 into 13 goes 1 time, and 13 into 26 goes 2 times. So reducing this, I have 1, I'm going to leave the 1, and then I have my bracket 1 minus I. Then we have 2 in the denominator, and this is the same as having a half and then the bracket 1 minus I. So I'm hoping you're seeing why I left the 1, because the half represents lambda. So remember, the question asks us to write in a specific form. So lambda is the coefficient, what's in front of the bracket. So therefore, I can state the value of lambda. Lambda is a half. And that's it. The next question asks us to verify that this is a real number and state its value. Now, I've already worked out the fraction area where it is the same as a half, open bracket, 1 minus I, close bracket. So I can replace a fraction with that and raise it to the power of 4. Now, this, remember it's coming from the previous activity. Since it's raised to the fourth, it means everything within is raised to the fourth. So a half is raised to the fourth. So I can rewrite it as a half to the power of 4. And also 1 minus I is also raised to the power 4. Now, this raised to the power 4, the fraction is just 1 over 16 because 2 to the 4th is 16. But the fraction we can't just, well, you could have expanded it 4 times or use Pascal triangle to expand this. However, I will be using binomial formula to expand 1 minus I raised to the power 4. What is binomial formula? It's NCR A n minus R B R. Now, what is n? What is R? What is A? And what is B? So to expand this, I have to identify that n is a power, which is 4. So n is 4. Next, I need to identify what is A. A is 1. That's the first term in the bracket. And what is B? It's going to be minus I, which is the second term inside my bracket. R starts from 0 and it stops at n. So R will be 0, 1, 2, 3, and 4. So we are going to substitute these values and letter, which is a complex number, into the binomial formula. So we'll be substituting r equals 0, then r equals 1, then r is equal to 2, followed by r is equal to 3, and finally r is equal to 4. So let's start with r equals 0. So we'll be substituting into the formula. So where I have n, I replace it with the number 4, rewrite c, and then r is now 0. A is 1, so I replace here to be 1 raised to the n minus r, so n is 4 and r is 0, so it's 4 minus 0. Then we replace what is b. B is minus I, so I replace here to be minus I raised to the power r, which is 0. Now we're going to do the same thing when r is equal to 1, but everything remains the same except r. So where I have the zeros, I will be replacing it with 1. So I will have 4c1, then I have 1 raised to the 4 minus, instead of 0, I'll have 1. So 1 raised to the 4 minus 1. Then minus I raised to the 1. Then we're going to do when r is equal to 2. So when r is equal to 2, I replace the 1s with 2. So what I'll have here is 4c2. Then I have 1 raised to the 4 minus 2. Then I have minus I raised to the power 2. For r equals 3, I will be doing the same thing. So wherever I see 2, I replace it with the number 3. So only r changes. So I have 4c3, then 1 to the 4 take away 3. So 4 minus 3. Then I have minus I raised to the power 3. Finally, I need to do r equal 4. So where I see 3, I replace it with 4. So I have 4c4, then 1 raised to the 4 minus 4, and then minus I raised to the power 4. Now, what is left for us to do is just to simplify what we have here, and we'll get the expansion for 1 minus I to the 4. So just simplifying, that's all. Now, when you have 4C0, you would enter 4NCR0 in your calculator. So 4C0, that is 1. 4 minus 0, the power is 4, but when we have a base 1, it doesn't matter what's the power. Here, it is just 1. And then anything raised to the power 0 is 1, so this would be 1. Plus 4C1, that is 4. So you can enter 4NCR1 in your calculator. So 4NCR1, that will give you 4, times 4 minus 1, that's 3, but anything, once you have a base 1, you will get back 1. Now minus I to the 1 is just minus I, so that's why I have a minus I. Now 4C2, so having 4C2 in your calculator for NCR2, that gives you 6. And then 4 minus 2, that's 2, but 1 squared is just 1. So here I'll have a 1. Minus I squared, that will give us positive. So you square it, so it becomes positive I squared. Now the next one is 4C3. So for NCR3, that is 4. And 1 raised to the 4 minus 3 is 1. So we'll just have a 1 here. So times 1. And then minus I cube, because the power is odd, you'll keep the negative sign. So we'll have minus I cube. Now the next part, 4C4, which is 4NCR4 in your calculator, that's 1. 4 minus 4 is 0, but 1 to the 0 is 1. Because we have an even power, it means we'll have positive. So this is positive I to the 4. So just to simplify, what do we have here? 1 times 1 times 1, that's 1. So right here, I'll just have a 1. 4 times 1, that's 4 times the minus, gives me minus 4i. I squared is negative 1, so that means 6 times 1 times minus 1, that's minus 6. Now negative I cube, you have I squared times I cube is I squared times I. So I can rewrite this part where we have minus I squared times I squared is negative 1, so that means it changed the minus sign here to positive, so I'm just left with positive I. So 4 times 1 times I, that is 4i. Finally, I raised to the power 4. Remember, I to the 4th is I squared times I squared. So that is negative 1 times negative 1. So that's positive 1. So 1 times 1 times 1 is 1. Now, minus 4i and the plus 4i cancel. So I have 1 minus 6 plus 1. So that's minus 5 plus 1. That's negative 4. So 1 minus I raised to the power of 4 is the same thing as negative 4. So right here, I can replace it with negative 4. So I have 1 over 16 times negative 4. And to simplify this, 4 into 16 goes 4 times. So that means I'm left with a minus 1 over 4, because don't forget the sign. So the real number and its value is negative 1 over 4. And that's it. The final question, we are given the complex number z is represented by the point T in an argon diagram. Given that z equal 1 over 3 plus it, where t is a variable, and z, if you realize z bar, denotes complex conjugate of z, show that z plus z bar is equal to 6 times z bar times z. So first I'm going to look at the left hand side. I'm going to have z to be 1 over 3 plus it, and then the conjugate means we change the symbol in the center from plus to minus. So adding this, we need to find the LCM. The LCM is like multiplying the two denominators together. So we have 3 plus it times 3 minus it. If you're wondering why, just think of when we have fractions. So for example, I have a half plus 1 over 3. If I ask you what's the LCM, we know it's 6. 3 times 2 is 6, which is the lowest common multiple. So that's how we come up with this scenario. Then you would say 2 into 6 goes 3 times, so 3 times 1, that's 3, plus 3 into 6 goes 2 times, so 2 times 1, that's 2. So that's the same concept, the 3 plus it into the denominator, left with 3 minus it times the 1 in the numerator to give me 3 minus it here, plus 3 minus it into the denominator. I'm left with 3 plus it multiplied by 1 in the numerator, so I'm left with 3 plus it. Minus it and the positive it cancel, so in the numerator 3 plus 3 gives me 6. Now in the denominator they are conjugates, so that means I can realize that I'm going to get 3 times 3, that's 9. The center will cancel, and multiplying it times minus it, that gives you minus I squared t squared. Now I squared is -1, so that will change the center to a positive, so I have plus t squared. Now I need to prove that the next side is the same, which is 6 times z times z bar, which is the conjugate. So I have 6 times z, which is 1 over 3 plus it, times z bar, which is 1 over 3 minus it, then multiplying 6 times 1, that's 6. You realize I put 6 over 1 so that you understand better. And once again, it's difference where you can see that this is a conjugate. So 3 times 3, that's 9. The centers would cancel. So I'm left with minus it times positive it to give me minus I squared t squared. Now I squared is -1, so that will change it to a +1. So I have plus t squared. So as you can see, the left is the same as the right, so I have proven what we were expected to do. Now the final question states that we need to show that as t varies, t lies on the circle. And I need to state the coordinates of the center of the circle. Now the information we know is from part 1 that z plus z bar is equal to 6 times z bar. We know that z, you will have a complex number in this form, x plus iy. Remember they say it's t varies. And that means the conjugate would be x minus iy. So I'll be substituting this into the equation z plus z bar equals 6 and then z times z bar. So I replace z. Substituting in the left, I have x plus iy plus the conjugate x minus iy. And on the right, I'm substituting again x plus iy times the conjugate x minus iy. Now here on the left, these cancel, so I'm just left with x plus x, that's 2x, while on the right, seeing the conjugate be multiplied, the center will be cancelled. So x times x, that's x squared. X times minus iy, that's minus xiy. And then we have iy times x, that is positive ixy. And then here I have iy times minus iy, that's minus I square y square. So the center will cancel. So I can just look at it and see that minus xiy cancels with the positive xiy. I square is negative 1, so that will change to positive. So what I'm left with is just x squared plus y squared. Now, expanding these brackets, I will have 6x squared plus 6y squared. So in this line, I'll have 2x also being carried over. So I'll have 6x squared plus 6y squared. As I explained, that I'll multiply and then carry the 2x over the equal sign so it becomes negative. Now I'll be grouping the x together, so I have 6x squared minus 2x. Then I have plus 6y squared equals 0. Now I'll be performing completing the square, where I have 6x squared minus 2x. So I will factor out the 6 that's here, and that means I'll be left with x squared minus 2 divided by 6, that is 2 over 6, which is reduced to be 1/3 x. Now, since I'm doing completing the square, the method is that we find half the coefficient of x. So I need to find half the coefficient of x, which is minus 1/3. And when I find half the coefficient of x, I plus and minus the square of this. Alright, so let's go. I'll find half the coefficient of x. It means a half of minus 1/3. So half of minus 1/3 is another way. You can just multiply this by a half. It's the same thing. So minus 1/3 times a half is minus 1 over 6. So minus 1 over 6 is half the coefficient of x, which is half the coefficient of x, which is minus 1/3. So we add negative 1/6 all square minus negative 1/6 all square, and then I have plus 6y squared equal 0. Now the first three parts, I can rewrite this. So this is 6 open bracket x minus 1 over 6 all square. And here we have to multiply this by 6 if I'm clearing the bracket right here. So I'll have 6 times squaring that, I will have positive 1 over 36 plus 6y squared equals 0. Now I'm going to get rid of the 6 by dividing the entire equation by 6. So getting rid of the 6, that's common. So I divide the entire equation by 6. So all the 6 are gone. So I'll be left with x minus 1 over 6 all square minus 1 over 36. Because all the 6 is gone, divided that by 6. Plus, now y squared. Now, here I'm trying to see what's happening here. So if I carry this over, I will have x minus 1 over 6 all square, and I'll have plus y squared is the same thing as y minus 0 all square, still y squared, And carrying over the minus 1 over 36, it becomes positive 1 over 36, which is the same thing as 1 over 6 all square. So remember 36 is 6. So that's why it's the same thing as 1 over 6 all square. Now the equation of a circle, this is the equation of a circle, and I'm hoping you're seeing the relationship because the question asks what is the center, and I'm going to also give the radius. So the center here, remember I say state the coordinates of the center of the circle. So the center here is 1 over 6 for x and 0 for y. So my center is 1 over 6 and 0. And here I can also give the radius, which is 1 over 6 units. And that's it. I've solved this question. Thanks for watching, guys. Don't forget to like and subscribe to my channel. Have a great day.